This is the breakdown of how I made my game for my final major project. To begin, I tested the idea of having an enemy chase the player in the first-person game template that the Unreal Engine provides. I made a cube that upon detecting the player will begin to move towards them along a set navigational path along the ground. I connected Wwise up to the engine and attached a sound to this cube to test how it might work, and found that I could make a horror game based on this concept of sound. The sound that comes from this enemy can be attenuated in Wwise so the player will be able to pinpoint where it is. I decided that I would attempt to make the enemy invisible so that the player would have to navigate away from them using only their sense of hearing. With a game concept in mind, I began to create the level. To show off some different sound design skills, I wanted to create a level with 3 distinct areas that the player would travel through before they reach the enemy. The level consists of a forest, a cave, and a tomb, and each feature different contrasting ambiences, gradually shifting the tone from calm to creepy. With the single commandment of collect the statue in the corner of the screen, the player travels through the cave into the tomb, where they can then collect a mysterious statue. This causes a large boulder to block the entrance whilst also opening up the rest of the tomb. From there, the player's anomaly meter starts to crackle up until the enemy is triggered. The player must now avoid the enemy using their ears and the anomaly meter, which shows the distance from the enemy, as one touch will result in death. The player then needs to traverse the tomb, press the button and exit to safety, completing the game. I decided to use Wwise to implement the audio, as it is an industry standard piece of middleware that allows the sound designer to create complex audio systems without the need for coding. It offers great flexibility with the ability to use features such as randomization, seamless switches, real-time parameter curves, and built-in audio effects, to name a few. Wwise is set up in a hierarchy system that allows me to group my sounds together and easily track and route my sounds. Sounds are placed into containers which can be turned into events. These events are sent into Unreal Engine so that they can be easily implemented into the game where needed. For the footsteps, I went out and recorded myself. I took these recordings and chopped out the ones that I liked. I then split them into a layer of first impact and a layer of the foot leaving the ground. When exporting these, I made use of Reaper's batch rendering to speed up the process immensely. Within Wwise, I created a switch container which allows switching from dirt footsteps to grass or to stone, depending on what surface the game is telling Wwise that the player is standing on. Each surface material within the switch container is a sequence container. These will complete a set of actions in a selected order. In this case, the grass sequence container will trigger a left foot, which will play a random sound from the left foot random container, followed by a right foot doing the same action. The right foot steps have a slight pitch increase to give an obvious right foot left foot feel. Also, to give the illusion of right and left foot movement, I edited the speaker panning position ever so slightly to the right and left for each corresponding side. This emulates how a foot will be ever so slightly panned to our ears while walking. With Unreal, I set up a list of physical materials that correspond to the surfaces in my game. On the player character blueprint in the footsteps section, I used the line trace by channel node to cast a line to the ground that the player is standing on every frame. This then determines which surface the player is on and sends this information to the set switch node, which talks with Wwise and changes the surface within Wwise. Post-event nodes are the way in which sounds are played from Wwise within Unreal. Here is how the footsteps event is posted within the player character blueprint. Here's how the footsteps sound in game. Each of the sections of my game require suitable ambiences to bring the world to life. The zone's ambiences consist of a 2D ambience bed that plays across the whole area, supplemented by various 3D positional sounds. As the player can move freely between the sections, ambience needs to seamlessly crossfade between each as they move throughout the level. To do this, I imported my ambience beds into a blend container which I attached to a game parameter that I named level progression. This then allows me to crossfade my sounds based on a range of values. In my case, 20,000 corresponds to the beginning of the forest and 0 is the furthest away part of the tomb. Using this Unreal blueprint, I defined the range and then updated the game parameter as the player moves throughout the level, giving smooth transitions in the form of crossfades. The forest consists of an ambient bed of wind and birds combined with sound emitters for wind blowing in the trees and birds flying around. To create a realistic movement of the trees, I used a loop of wind recording and attached a real-time parameter control, RTPC, to it that would affect the volume and low-pass filter settings. This RTPC was controlled by a very slow LFO that is set to randomize in frequency between 0.08 and 0.2 in Wwise units. This gives a very subtle rise and dip to the wind sounds in the trees that feels organic. The attenuation curves on these wind sounds means that walking on the path causes the player to hear the wind coming from the side that the trees are on. On many sounds in this project, I used the spread function in the positioning panel. This curve makes the wind sound 2D when in the middle of the trees and more 3D and directional when further away. Also around the trees there are randomly triggered bird sounds that are scattered using 3D automation. This feature allows me to set multiple paths in which the birds can be triggered from the stereo field. The pond area was made of loops of lapping water placed around the pond for coverage. The sound of insects is made of a simple serum wave and has an LFO automated peak and band EQ to create the sound of a chirping cicada. The cave's ambient bed was created using a recording of the extractor fan in my kitchen that's been pitched down with added reverb. I then automated a frequency shifter using an LFO within Reaper to give some movement to the sound to make it less static. The dripping sounds were of individual drip recordings captured from my kitchen sink. The flashlight was created by layering multiple clicky sounds to create a satisfying on and off input. As the player enters the cave, the reverb in the area can begin to be heard on the footsteps. To add reverb using Wwise, I created auxiliary buses for each type of reverb that I needed. I then add the reverb in the effects panel, and then in the actor mixer hierarchy, click Use Game Defined Auxiliary Sends for the sounds that I wish to have reverb. Here, for example, I wanted all of the sounds associated with my player to have reverb, as these sounds are directly localized to the player. Within Unreal, I created an AK reverb box that can be seen here in orange, and attached my auxiliary to it. This will affect the player as they walk into that area. The sound emitted from the statue was created using a metal hit sound that rings out. I stretched it, added effects, and re-recorded the tail. I then split up the high and low frequency content and used the same frequency shifter technique from the cave ambience to give it movement. In Wwise, I split this sound into its low and high components and gave each sound a different attenuation curve so that the low frequency part could be heard through the wall before the player reaches the statue. The statue collection sound was created by layering sounds of keys and grabbing a ceramic bowl. The sound of the monster adapts based on the location of the monster from the player along the path that it is allowed to take along the floor, showed here in green. In the blueprint for the monster, I set a process to work out the distance from the player and to assign that a value from 1 to 400. I then created an RTPC in Wwise called Distance from Player and had Unreal Engine update this parameter every frame. I could then use this dynamic value to affect what sounds will play depending on the distance value. Using a blend container, I set up 3 zones that will change how the monster sounds depending on distance. These include a quiet low-pitched sound when it's far away, a mixture of that low-pitched sound and a scary vocal type layer, and the previous 2 layers plus a randomized layer that adds louder, scarier elements. The first sound for the monster was created using a recording of my coffee machine. I pitched it down and added various effects to give a deep sound. The middle layer adds a serum patch I created, and the final layer includes a different serum patch that is a collection of serum one-shots. To add a slow build-up to the monster reveal, I created a Geiger sound that increases in intensity by attaching a blend container to the enemy distance value. To increase the intensity, I use gradually increasing amounts of bit crusher over the course of 4 variations of loops. When the player gets within 20 units of the enemy, a low pass filter cuts out almost all of the sounds, revealing the sounds of breathing, a heartbeat, and Geiger counter static. This was achieved using states within Wwise. States allow the user to create sweeping changes to the sound in the whole game, and in this case, I used it to creatively build up the scare factor as the enemy gets close. In Wwise, I created a state group with the states close and far contained within. I then chose how long the transition would be when the sound goes from close to far and vice versa. On each collection of events that I wanted the states to affect, I added the state group to them and chose how much filter to add for each. This leaves me with some sounds that turn down and get filtered, and some sounds that get faded in. If the player gets hit by the enemy, they die and can choose to try again or quit the game, and are greeted by a scary sound from the monster. If they succeed, they get the same options and are greeted with a win sound. This concludes the explanation of the major aspects of the game. More detailed information can be found on my blog. Thanks for watching.